Okay, so here we've got a little bit of modelling with differentiation. How do I know it's about differentiation? Because it wants a cost that minimises the minimal cost. Well, we're dealing with a curve here, so when the curve turns, the gradient will be 0. So what we need to do first of all is change this so that we've got powers of v. So I would call c equal to 1500 v to the negative 1 plus 2/11ths of v plus 60. And then we're going to differentiate c by v. And we drop the power by 1 and we multiply by the negative 1 that's there already, so it's minus 1500 v to the minus 2 plus, if you've got a power of 1, that v just drops away, doesn't it, plus 2/11ths. So that just leaves us with that. So now what does that mean? That means minus 1500, and we want that to equal 0, minus 1500 over v squared plus 2/11ths equals 0. That means I could add this over to this side, doesn't it? So if I added that over to that side, I would have 2/11ths equals 1500 over v squared. I could then multiply by v squared to give me 2v squared over 11 equals 1500. I can then times by 11 and divide by 2. I'm going to do that in one go to give me v squared equals 1500 times by 11 divide by 2 gives me 8250. So v will be root 8250. So the square root of the answer is 5 root 330. Now we want some money here, don't we? So we better S to D. That gives us 90.83 to the nearest penny. Oh, hang on, it's not pennies, is it? It is kilometers per hour. So we're going for 90.8 kmh. And the minimum cost of the journey is going to be the cost when we use that value. And we can get it exact by remembering that we've got the answer in here already. So the cost is going to be 1500 divided by 90.8, but I'm just going to put answer in here when I do it, plus 2 times 90.8 over 11 plus 60. So I whack that into the calculator like this, over shift ants, plus 2 times, use the ants key again, over 11, add 60 to that, bish bash bosh, there's our answer, which S to D will tell us 93.028, and that time we do need to have it to the nearest penny, don't we? £93 and 3 pence. Now the next part, it tells us what to do. Prove by using this, so that means differentiating again, that the cost is minimized at the speed found in there. So all we need to do for that is start off by doing d2c over dv squared, which is going to be this differentiated again. So I'm going to go multiply by negative 2, and that's going to give me 3000 v to the negative 3, and that's just going to fall away, isn't it? So that's all of it is. But in order to prove that it's minimized, we now need to put the speed 93.03 in there and see what comes out. So 3000 divided by 93.03 cubed. Put that into the calculator as, what was it, 3,000 over, it'll still have, it should use that answer this time, to the power 3 equals, now that's a pretty small number, but it is a positive number, that's what's important, to the negative 03, that is 0.0033726, and that is bigger than 0, so it is a minimum. So a positive result proves it's a minimum, a negative result that it's a maximum. Final, for only 1 mark, state one limitation of this model. Well, for that, you need to go back and think about this. Is a lorry ever going to be driven at exactly the same speed all the way from London to Newcastle? No, that's not really possible, is it? So that's all you've got to write. It's not really possible to drive at exactly, what was it, 90.8 kilometers an hour, all that distance. So something like that.